Hello, my name is Mr. John Smith, and I have been visiting my hometown for the winter break. You see, we live in Florida, where there is not much snow. Yes. Now, I don't remember what our town is called, but it was a very, very creative name, made by the founding fathers. Ahoy there! Welcome to Town, the town of the towny townsmen. You see, in the cell at the very center, there's something called the nucleus. The nucleus stores the cell's genome in DNA, and then it is transcribed into RNA. RNA then exits the cell through the nucleolus. Oh right, why does it sound like there's a turbine in the background? Anyways, the RNA exits the cell, and then it goes towards the ribosomes, which transcribe the RNA into protein. Very well then. Let's transcribe some of this wonderful book stuff, which is our way of storing information, and we'll go take it outside. Ooh, look at this. I've got a book. You must be very quiet in the library. That means no turbine. Well, if you refuse to stop the turbine, I guess we must be very loud inside the library. Anyways, let's go. You see, the librarian is like the nucleolus. It controls what goes in and out of the library. If I were to check in a book, I would toss it to him. If I were want to take it from him. Thank you. Have a great day, sir. Now that we have our wonderful book, we may toss it on the floor and not care about it. Just kidding, we need it. La 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 la, sing a happy song. Now, we've entered, oh, not quite entered yet, but we have arrived at the factory. Yes, the factory is a wonderful place. In a cell, this could represent the endoplasmic reticulum. You see, in the endoplasmic reticulum, we read the book, and then we learn how to make these wonderful things. See, over here is like the rough ER, because over here we have ribosomes. Now, the workers here read these wonderful books, and then they can make protein. In this factory, instead of making proteins, we make very loud iron. This is made of solely pure American steel. Alright, sorry if that was understand. I did not have my coffee. But the point is, there are two parts of the endoplasmic reticulum. One side is the rough end, and the other is the smooth part. The rough part is called rough because it's studded with many, many ribosomes. Ribosomes take the information from the RNA over here, and then they use it to make protein, just like this worker over here. Hello, worker. I said hello, worker. Worker? Oh, hello there. Is it true that you, read books? Exactly. Now, they take the R day, and then after converting them into proteins, they can make the proteins and bundle them up and create them into certain enzymes or such, and then send it along the very long double-membraned railroad across to most likely the Golgi apparatus. Now, instead of reading RNA, the workers, instead of the ribosomes, read books to teach them how to make these raw iron instead of protein. Now, this protein is later smelted and transported across this railroad. Now, the smooth yarr does two things. Well, two primary things. It detoxifies drugs such as alcohol, and it also creates lipids, which are the main building blocks of our cell. Yes. We can think of the detoxifying part like this wonderful, partially built hospital. Not quite done yet, due to lack of resources. Or, we can also think of this smoother, get it? Smoother, smooth, E-R, no. Because the smooth, here, smooth as bricks, which are the main building blocks of our buildings. Bricks. Yay! Back to your viewing pleasure. Let's go to the post office, which represents the Golgi apparatus. Now, of course, in a cell, the Golgi apparatus would be farther from the nucleus than the smooth and rough ER. But of course, this is a town and not a cell, so some things are different. Yes. Nor snow, nor rain, nor heat, nor gloom of the night. Now, the very one important thing that I came back here for the winter break is that the post office is where Santa lives. Indeed. I can't fit in the door. There we go. Now. Hello there, Santa. That's right. Hello, Santa. What a fine day it is today. Now, what happens in the Golgi apparatus of a cell is that the contents from the rough and smooth endoplasmic reticulum are packaged into little vesicles and then sent on their way. Often, the Golgi apparatus puts a carbon mark onto the vesicle, telling the vesicle where to go. Well, not telling, because no organelle is living. Yeah. Oh, why, thank you, Santa. But I do believe that you are not supposed to give sugar cane, but I do believe you're supposed to give candy cane. I'll just trash that. Anyways, the Golgi apparatus packages many different vesicles. One of the kinds of vesicles are lysosomes. Ooh, wonderful. Fragile, a pack of screwdrivers. Screwdrivers, you see, are wonderful, wonderful things. In a cell, you could think of them as enzymes. Enzymes fit perfectly to their substrate and apply tension, reducing the activation energy required to start the reaction. For screwdrivers, we can unscrew screws that could not be normally screwed with our bare hands. Bare hands, yes. In a cell, what the lysosomes do is that they take the, let me think about this for a bit. I must sit by the pond and swim a bit. The lysosomes are enzymes enclosed in vesicles to protect them, like this little box, which states fragile because screwdrivers are extremely fragile. What the enzymes help us do in the cell is that they are able to break down large particles that we could normally not break down by normal uses of the cell. These enzymes will latch onto large particles, which they fit perfectly at the active site, like bacteria, so then they can kill the bacteria. And also, large particles such as worn out organelles that the cell no longer uses, and other large particles like digesting food. Yes, I remember. Now, let's test out these lysosomes. Let's open this package that was not meant for me. Many screwdrivers. Yes, those are screwdrivers, no comment. What can we do with screwdrivers? We can unscrew large organelles that we no longer need. And we may also use it to get rid of scary bacteria. Oh no, it has certainly unexpectedly turned nighttime all of a sudden. Oh no, look over there. This is absolutely horrifying. Luckily, I can use this screwdriver to dispatch of dangerous threats. Yes, I can. Wonderful. now this wonderful village is safe once again, thanks to the wonderful help of me and my screwdriver lysosome. Yeah. Yeah. Now, for the mitochondria. The mitochondria creates energy in the form of ATP by forming unstable bonds between the three phosphate groups. Here, you can represent these three phosphate groups as this little gasoline pump. Yes, BP, Bob's Petroleum, not British Petroleum. This wonderful petroleum can be used to fuel my wonderful car. Yeah, car.
This little light of mine, I'm gonna let it shine.
Yay, car. Or we can use this wonderful British petroleum to fuel that wonderful atrocity of a turbine. You insist on keep on powering. I hate turbine noises. Oh right, for tourism purposes, we mustn't forget the wonderful new museum that our town has created. Oh, looky here. There seems to be a lucky special exhibit and a lucky oh, it's just the museum. Well then, of course we must have to pass the security of this museum. Hello. Oh, what do you mean? I can't carry a screwdriver into the museum. Oh well then, very well, you can take my screwdriver. This security examination is like the membrane of a cell. You see, it surrounds the cell, keeping the outsides out like this wonderful, tough construction wall. Tough construction, I'll place that back. Wall. Yes. Because it lets certain things go in, and what? I can't go in even now? Oh, I must pay money to go into the museum. Yeah, fine, you can take your money. Yes, now the membrane lets certain things go in, certain things go out, and certain things to not be able to come in, and certain things to not be able to go out. Like this wonderful special exhibit, the blue balloon. Wow, that's a wonderful blue balloon.
This is the balloon song. Sing along with me. Blue, blue balloon, drifting out so high.
You see, this wonderful blue balloon can be thought of a miniature version of a plant cell. You see, the plants, this balloon has much fluid, air, inside of it, which presses against the cell wallish, I don't know what you call the outside of a balloon, but it's called the balloon, I guess. Presses on the balloon, maintaining its circular shape, which makes little children happy. Like Santa likes to make little children happy. Yay! Well then, I could say that was a wonderful exhibit. Yes, it was. Now let's leave, and I don't want to come back here again. That was a horrible museum. Now, for the final thing, the pride and joy of this wonderful town. The meat bakery. La 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 la, better walk on the sidewalk. here we are, the wonderful meat thing. Here we take the sun's light energy to cook our wonderful juicy steak. This steak is used to fuel our tummies and it tastes good. It is sort of like how a plant uses its plastids/chloroplasts to take in the sun's light, use it as energy to transform carbon dioxide into wonderful juicy sugars in which it uses for energy. Energy, energy, energy. Now better ring on the doorbell before we come in. Wonderful doorbell. Alright, so now over here we have the uncooked fuel, and we have the raw beef in which we want to cook. Here we use the solar panel, sun's rays. Let's just turn on this solar panel, and now since we've pressed on the solar panel button, we are cooking our wonderful juicy steak. Yes. Allow me for a demonstration. Alrighty then. La 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 la. Oh, I'm gonna go jog several laps. Oh, I seem to be getting tired and in need of energy. Oh, what a pity. Where do I get the energy from? Oh, lucky, lucky. I seem to be hungry. Time to eat my juicy steak. Now my hunger is satisfied. Well then, I sincerely hope that you have enjoyed your stay with me during my vacation in my wonderful hometown. We do hope you visit again for the sake of tourism and good economy, because we paid the museum. Well, I must be off. Have a great day. As long as there is trouble in the world, I have to fix it. Now, see ya.